needs help can watch. All right, no talking, let's do this. God bless you. All right, we are talking about identifying a slope from a line on a graph, okay? Now, here's the good news. Technically, with these lines, you can get a clean intersection just by going from the very first part of the line to the very last part of the line. All of the lines on this worksheet, hello, all of the lines on this worksheet, you can count like all the way from here to all the way to there. But that will require some simplifying in most cases. We can also identify any spot where the line cuts through an intersection perfectly. I'm noticing on this one that it cuts through the origin perfectly, right? So that can be a point. I'm also noticing that this line actually cuts through every single intersection perfectly. Do you guys see that you can identify any other point on this line? So I'm choosing to start with my origin and then go to that next clean intersection. Another thing you want to do with slope is look at the line and say, and just answer it to yourself first. Is this a positive slope or a negative slope? Is it going uphill or downhill from left to right? It's going downhill, so is it positive or negative? It's a negative slope, so we know that it's going to be negative. It's something to keep in mind so that we don't mess it up at the end, okay? The other way to acknowledge that this is a negative slope is that your rise from this point to this point isn't going upward. The rise is falling, okay? I know it's called rise over run, but sometimes when it's negative, it's more like a fall over a run. So our rise is a negative one. That's how you get to the line to go over, right? So a negative one over how much? Positive one, right? If it's moving to the right, it's positive one. Now, is that a simplified slope? No, it's really close though. How would you simplify negative 1 over 1? Yeah, and you'd get what? So negative 1 is your slope. When your slope is a fraction that can be simplified, reduced, divided, you have to simplify it. If it's a fraction that cannot be reduced or divided, then leave it as a fraction, okay? Ready for the next one? I'm gonna call on you guys, I want some participation. All right, number 2. Melanie, I want you to help me with this one. Did you get an answer for this? No? Okay, I want you to help me with it, okay? Did you identify any point on this line as kind of like a starting point? Again, you can pick any starting point that is a clean intersection. I have my eye on a very clean intersection. Do you see a clean intersection? You don't see any clean intersection? From here all the way to here, do you see where the line intersects cleanly? -3 on the x, right? We call that our x-intercept, but that doesn't really matter right now, but it is intersecting the x-axis at -3, 0. So that can be our starting point. Then I just kind of scan down the line and look, no, 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 ding, 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 ding. This is a clean intersection because it's going right through that little plus sign right there. So we're gonna have to do a lot of counting for this one. Is the slope positive or negative? Negative. It's going downward from left to right. So we're going to be rising downward, which is a negative rise. So when we count down, we go 1, 2, 3, 4, 5. So that's -5 over, Melanie, what do I do next? What is it? What? 2. So we go over to the right, 1, 2, to get to our next point, and that would be 2 to the right would be +2. So we have a -5 over 2. Is this simplified? No, yes, is it? What do you guys think? It is and it isn't. Isn't that weird? Now, are we okay with the numerator being a bigger number than the denominator? Yes, we call that an improper fraction, which sounds like a bad thing, and in elementary school it was. In elementary school, they always made you convert your improper fractions to mixed numbers. It was like, you can't have a numerator that's bigger, you have to divide it, and you'd get 2.5. Well, we don't write slopes as mixed numbers, we write them as improper fractions. Can this be divided, reduced? No. So, the way to simplify it is to make sure that acknowledging that this slope is negative is acknowledging that the entire fraction is negative. This is totally correct, 100% correct. This is also correct. It could also technically be a positive 5 over a negative 2. When you have a negative fraction, a negative slope, it means only one of the numbers is negative. So this is correct, but this is the way we write a slope as a finalized slope. So this can be simplified other than the fact that the negative, if only one of them is negative, that means the fraction is negative. So we write the negative outside of the fraction. Does that make sense? It's starting to smell really good with whatever they're cooking up today. All right, let's go to the next one. All right, I think this one was kind of tricky. Let's look and see what clean intersections we have. We know we have this one, right? But let's just look. Does that look like a clean intersection? Looks like it's close, but it's a little above. No, no, no. Oh, it's so close. It's so close to a clean intersection. No, no, boom. So we're gonna have to go all the way from here to here to count our rise over run. This one's a little tricky because some of the intersections, it's like that, have you ever seen, this might be, you guys don't use DVD players, so this might be like not relevant for you. Okay, you know the little DVD that bounces from edge to edge of the TV?
Yeah.
If anybody's ever watched The Office, there's an Office episode where they're watching the DVD bounce from and they're waiting for it to go into the corner kind of thing.
Yeah, Miss Reaver showed us that much.
Oh, she did. Okay, so, oh, and I think we did an assembly last year. Yeah, there was an assembly, but I thought it was just for the 8th graders last year.
It was just
Anyway, so this is one of those that really your only clean intersections are here and here. These are the ones where it's like so close, it's like, is it gonna hit, is it gonna hit? No, it doesn't, so you have to look really, really carefully. So we have clean intersections here and here. We're gonna have to count our rise over run. Now, is this a positive slope or a negative slope? Just by looking at it, is it positive or negative? Positive, it's going up from left to right, so it's a positive slope. So that means when we count from this point to this point, we're counting upwards, right? This is going to be our rise. 1, 2, 3, 4, 5, 6, 7. Positive 7 as our rise, because it's going up. And then it's going to the right. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can that be reduced?
No.
Nope. So your slope is 7 over 10. Is this making sense?
Yeah.
Number 4. Let's see if we can get some clean intersections. Anybody see a nice clean intersection? Yes. Yeah, the y-intercept is a clean intersection, right? There is a positive 3, or I should say 0, positive 3 as the coordinate pair. It's the positive 3, it's the y-intercept. Girls, I need you to be paying attention. Thank you. It's okay. So we're going to start with this point. Let's look for our next clean intersection. No, 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 yes. Okay? So we're going from this point to this point. Is it going to be positive or negative?
Negative.
Negative, because it's going downhill. Okay, so that means our rise, which we always count the rise first, right? The rise is our numerator. So we count the rise first. To get from this point to this point, we're going to rise downward, which is a negative rise. So we would call that what? What is it? What's our rise?
1. No, it's -1.
Negative 1. Good. So we're rising -1. And then we have to go over to the right. 1, 2, 3, 4, 5. How do we write this in the perfect slope formation?
-1/5.
Good. Negative on the outside of the fraction, 1/5. You guys good?
Yeah.
Number 5. Okay. Does anybody want to come up here and try it? And just, it can only be people who, the parents checked the, yes, my child can be photographed thing, just because this goes on YouTube and people can Okay. Okay, as long as you are somebody who is allowed to be on camera. Emily, you want to come up and try it?
Not for me on their Facebook all the time. Our mommy don't.
Yeah. Oh, she found a clean intersection. I like it.
I wish my mom would make this picture.
Oh gosh, that's funny. Okay, say what you're doing while you're doing it.
Clean intersect. Clean intersect.
Good, intersection, yeah.
And then 1, 2, 3, 4, 5. This is negative, right?
Yep. You can see that the line is going downward like a slide. That's perfect.
-5/2.
Yeah, and she already even put the negative on the outside of the fraction. That's perfect. -5/2 is correct. Who wants to do number 6? And is allowed to be YouTube famous.
Oh, yeah.
Who wants to do number 6?
I got if you show me the answer on
I promise not a lot of people watch my YouTube other than my algebra students. So, yeah, I'm just saying, like, you don't have to worry about, like, it's not like I have, like, millions of subscribers that you're going to be like, oh my gosh, I don't want everybody in the world to see me do the problem. It's just, like, use guys.
I'm pretty sure.
So,
I'm pretty sure you have a couple million.
so one day we're going to hit that million mark.
But I won't do 6.
You will do 7. Okay, well, is anybody willing to do 6? Or have anybody for 6? Going once, going twice? Emily, oh.
Eventually, like maybe in 10 years, it will hit 1 million. Like, because every single 8th grade class will subscribe.
Yes! And then I'll get famous and rich.
I need to talk harder to talk to subscribe.
Oh, that'd be fun. All right, so, and you got to do your teacher stance where you stand out of the way so everybody can see. Tell us what you're doing as you're doing it, or what you're looking for.
So we've got the clean intersect here, and then here. Just count.
That looks good to me. I'm trying to see if I see any clean intersection. I actually don't.
Yeah.
The good news is, if we're missing one of the clean intersections, we'll find out by seeing a fraction that can be reduced. But if the fraction can't be reduced, then we'll just leave it as is, okay? Okay, so we have to pause for a second. You erase that, and I'm gonna give you some instruction, okay? We always go from our first point to our second point, left to right. So this might be, it might be harder for left-handed people. I have 2 left-handed sons, so it might be, are you left-handed? Okay, is it harder, is it kind of hard for you to count the?
I don't know, I just do this in my head.
No.
Okay, so it's, when you read a slope, when you're counting your rise over run, you have to do it like you're reading a book. Like from left to right, like reading a sentence, okay? So pause. Okay, so which point is on the left side of the Good. So start there.
And then I just go up this way?
Yeah, because we have to count our rise. So what'd you count?
10 over 3.
Good. Now stay up there, and I'm actually going to have to, go ahead and write it. I'm going to tell you that it is okay to go backwards also, as long as you acknowledge what signs it should be. So try counting backwards from right to left.
What?
So do it the way you're going to do it, okay? Okay, so if you count downwards 10, how would you write that?
Negative 10.
Negative 10, go ahead and
I
write.
just
No,
know
you're good, you're
the
good. Write a
slope.
negative 10. Yeah, you can, okay. Now, when you got to the bottom, what did you do?
I just went across.
Now, you went across, but you didn't go from your stopping point to the point. You let go of your stopping point and you went over to the point and you counted backwards. So, what I'm telling you is you can get the right slope by counting downwards and then over, but once you count downwards, you have to count, because I noticed that you went downwards and then you lifted the marker, went to the point and then counted to the right.
I don't really know how to like.
It's okay.
I'm
just-
doing it in my head.
Right.
And then I just also just count, and then I just know because of the slope.
Okay.
Like,
And
the
that's
line, I
totally
just know
fine.
that it's
But I just
possible.
want to show you guys that you can count downward and get negative 10. Then once you're here, you can count to the left 3. 1, 2, 3. What would be left 3? Left 3. Negative 3. So write a negative 3. Good. Good. If we simplify a negative 10 over negative 3,
It'd be positive.
it would be positive. So it'd be back to 10 over 3. So I'm just letting you guys know that it's actually okay to go from the left to the right as long as you acknowledge positives and negatives appropriately. So negative 10 over 3, I'm sorry, negative 10 over negative 3 is correct. Simplified, it would be positive 10 over 3, which is what we got from doing it this way. So we're good. Good job. All right. Number 7. Angeli, why don't you try come up here and do it? Are you okay? No, not so much? Okay. Callie? I want to play you Callie. Has anyone ever called you that before? Well, that's a start. Make sure you got your teacher stance going on. Tell us what you're doing as you're doing it.
What do you call that?
What do you call what? Points?
Yeah.
Yeah. So basically you're just finding points out of, I always just call it a clean intersection. I kind of base that term up. So I look for a clean intersection on the graph. Okay, so what'd you get? Good, 5 over 2. She went up 5, which is positive, over to the right 2, which is also positive. Can that be reduced? Should we change it to a mixed number? No, 5 over 2 is correct. Very good. All right. You want to do it? You want me to give you a hint? You want me? I can say it.
Abby do this one.
Abby!
Yeah, she can teach you while you're up there. Abby, but my parents don't want me on there.
Okay.
Yes, they do.
Yes,
No,
they
they
do.
don't.
Okay, I have to respect that.
She
Do
doesn't
you want to try
go
it?
up.
I will.
Yeah.
Abby, just saying this and you don't.
Yeah, that's what she should say. She just say
Oh, yeah, you can't because you
Yeah.
All three.
Good. Girls, pay attention. Got our student teacher working here.
This one or this one?
So you're gonna count from left to right. Okay. Good, negative.
Negative 1 over 10.
Perfect. Good job. So we write negative 1 over 10, or what our computers like us to do is write a negative on the outside of the fraction and then a 1 over 10. But totally correct. You guys did a great job. I think that's it for this sheet. And that is how we find slope from looking at a line on a graph. Tomorrow we're going to do more of this, but we're going to find slope using 2 points. But you guys can spend the next 5 minutes catching up on work, whatever you need to do.